Diagram of proton and neutron orbits. This is based on my premise that both protons and neutrons are made up of combinations of electrons and positrons, which are anti-electrons. This is only my idea and has not been verified. Please see my other posts for more. This diagram suggests that a singularity made of photons created electron and positron pairs in the Big Bang. Then those electrons and positrons in turn created the fundamental particles. Proton on the left consists of two shells that from inside out contain a single electron in the center, and orbiting it are two positrons in a single full orbital. The two positrons have opposite spin. Neutron on the right consists of three shells that from inside out contain a single electron in the center. Orbiting it are two positrons in a single full orbital. The two positrons have opposite spin. There is also an outer orbital that contains a single electron. Questions and answers on my model. Question: why are protons and neutrons so much larger than the electrons that are orbiting the nucleus? Because protons and neutrons contain mostly space, with one orbiting wave in the case of protons and two orbiting waves in the case of neutrons. That is also why neutrons with an added electron are slightly larger than protons. Question: why do protons have a positive charge equal to an electron? The proton has a positron, electron, and positron. The single electron and one positron balance charge. That leaves one free positron. That gives the proton the exact opposite charge of an electron. Question: why does a neutron have no charge? Answer: the neutron has two positrons and two electrons. The charge of the two electrons balance the charge of the two positrons and leave the neutron with a neutral charge. Question: why are protons always accompanied by neutrons in the nucleus, except in the case of hydrogen? Answer: the outer shells of the proton and neutron are opposite charge and different wavelengths, so they can coexist in the nucleus. Had the nucleus been all protons, their outer shell with its positive charge positron would keep them apart. Had the nucleus been all neutrons, their outer shell with its negative charge electron would keep them apart. Question: why don't the electrons and positrons annihilate each other? Answer: this is a difficult question. My best guess is this: free electrons and positrons annihilate each other and become pure energy photons. But we also know that electrons and protons do not annihilate each other. Why the difference? It may be because in the first case, the electron and positron are mirror image waves of each other, and destructive interference applies as it does with mirror image sound waves, etc. But in the second case, the proton is much larger than a single electron. Then too, the positrons and electrons are also in separate nucleus shells with different wavelengths. Remember that the wavelength of an electron changes with velocity, and electrons do not have fixed wavelengths. The same applies to the positron. Question: what holds the protons and neutrons together in the nucleus? The opposite charged particle in their outer shell. For protons, it's two positrons in a filled outer shell. For neutrons, it's one electron. Question: why are protons so stable, virtually immortal, and neutrons last about 10 minutes when outside the nucleus? Answer: the model suggests that a proton has a filled outer orbital with two positrons. This should make it very stable. Neutrons with an outer orbital of a single electron are not. There are instances, such as electron capture or beta plus decay, where an electron and proton combine to make a neutron, or vice versa, the neutron decays into an electron and proton. Question: does this challenge the quark, gluon, and strong force? Yes. Question: what other questions can this model solve? Answer: this can solve where the missing antimatter is. It's there in the atom's nucleus. The positrons in the proton and neutron are the missing antimatter. They have been in the atom all along. Question, can photons or light make mass? Answer, yes. Photons can make electron-positron pairs in pair conversion. Furthermore, high-energy gamma rays, photons, can create proton and antiprotons pairs in pair conversion. Question, what happened to antiprotons with a positron in the center and 2 electrons in the outer full orbital? Answer, best guess. They may have merged with a positron to make a neutron.